Thank you everyone for joining and welcome to the continuation of our virtual workshops. This is the Lakehouse Labs that we've created for Databricks and to learn everything about Databricks. And we have some really awesome people to show you some of the background of modern infrastructure and security on Databricks today. So before we get started, I'll give you a quick introduction about who I am and who Blueprint is. So my name is Ruthie Senanayaka, and I work at Blueprint as the social marketing operations manager. So I do all of the events and I get to do all the fun stuff. So welcome to our workshop, and thanks so much for signing up. We have quite a few workshops still happening in the future. So if you're interested and if you find this one super interesting, please do join us for the future ones as well. You can visit us at bpcs.com in the events section and sign up right there. But Blueprint is a technology solutions company, and we do everything from strategy to execution. So we work with a ton of different industries. So we have a lot of different use cases. And if you feel like you want to see how something like this can work at your organization, we're happy to connect with you and work on that. So you can always email us at info@bpcs.com to continue on this conversation. And if you have additional questions, you can also send it there. But you're more than welcome to ask questions live in this webinar workshop as well. You can easily ask a question in the Q&A section. Just click on the Q&A button at the bottom of your screen and submit your question. You can submit it with your name or anonymously, whatever you like. And I'm going to now pass it on to Brian Kepler and John Irwin, who are going to host this workshop for us. So take it away, Brian.
Thanks, Ruthie. Let me share my screen. Welcome, everyone, to Blueprint's workshop on modern infrastructure and security for Databricks. My name is Brian, and co-presenting with me today will be John. In this workshop, we'll be demonstrating best practices for configuring a cloud environment for Databricks Lakehouse platform. First thing to note here is there's a public repository on GitHub available with all of the Terraform configuration we'll be highlighting today, as well as additional resources to get you started. Today I'll be covering a brand new Databricks workspace in Azure using Terraform, along with an external storage account, a key vault, and a managed identity for the workspace called an access connector for Databricks that enables secure and maintainable data access policies. After that, I'll demonstrate creating a new Databricks metastore with another storage account that metastore will leverage. Finally, I'll show some examples of workspace administration configurations, such as assigning a user to a workspace group, cluster creation, creating a key vault back secret scope, and an external data location along with its accompanying storage credentials. By no means will this be an exhaustive demonstration of all of the Databricks configuration management you can achieve using infrastructure as code tooling like Terraform, but the goal, But the goal is to show you some of the power of using IAC tooling to manage Databricks and to get you excited to dive deeper on your own. After my part is finished, I'll throw it over to John for the roadmap on how to get your data moving in your new workspace. With that out of the way, let's get started provisioning resources. I'll be running this demonstration in Visual Studio Code, leveraging PowerShell as our orchestration scripting language of choice. I went ahead and kicked off the first of 3 configuration deployments. This will create the Databricks workspace, its external storage, the key vault, the access connector, along with some permissions assigned to the access connector. So let me go ahead and run our first configuration. And while that's running, I'm just going to go ahead and highlight what we're doing in this script. The first thing you'll need to do is authenticate with your Azure tenant using the Azure CLI, and then set the subscription to a subscription where you have the proper permissions to run all this stuff. The next thing we do is initialize the first of 3 Terraform working directories using the Terraform init command, and apply the first configuration using the apply command. Thing to highlight here is the init command initializes your Terraform working directory by downloading any required binaries for any declared providers. You can think of a Terraform provider as an API implementation that enables Terraform to create live resources you declare in the configuration files. Init also searches for any module declarations and verifies source pathing and gathers some metadata. Modules are bits of reusable Terraform configuration. You can think of them acting like a function in your favorite programming language. The root configuration directory is also consulted for any backend configuration and initializes that using given configuration settings. For all our examples today, we're setting up the Terraform state file to be saved in a remote storage container. This helps ensure we keep our state file safe from any accidental deletion or committing it to GitHub, as the state file potentially contains private data you wouldn't want exposed publicly. So let me go ahead and show you an example of our provider setup that we're using for this first configuration. We're using 2 providers. So we have a first party provider provided by HashiCorp for Azure Resource Manager. This allows us to create the resource group, key vault, and any other Azure resources that we need for our Databricks workspace. And then we also have a third-party provider, the Databricks provider, which provides us our ability to create the workspace. Later on, I'll show you creating the metastore and then also the workspace configuration. A thing to highlight here is that infrastructure as code tooling makes it easy to ensure best practices are followed. For example, we create a Databricks access connector in the Databricks module and assign that created principal ID permissions to access things like the external storage and the key vault. This saves you time from logging into UI, clicking around, and spending time looking up best practices you may have forgotten. Infrastructure as code tooling such as Terraform, it documents best practices in a human readable configuration file that you can use to deploy live resources. So you can see we're declaring a resource for our access connector. We're declaring a resource for our workspace. It looks like we've completed our first configuration here. We're gathering some variables, and then I'm going to kick off the configuration that creates the metastore. The metastore is in its own root configuration here. To separate the metastore's lifecycle from the workspace resources, given the fact that a region's unique metastore has a one-to-many relationship with the Databricks workspaces assigned to it in that region. This configuration creates a metastore object, assigns the Databricks workspace to the metastore, and it also creates another storage account for the metastore. So when you run Terraform apply, what it does is it reads that state file, it compares it to your declared configuration, and then it generates what they call a plan. And it just kind of tells you before you run it what this apply command will do. In our case, it's going to create 5 resources. So we have the managed identity data access, we have the metastore and workspace assignment. We actually create the metastore. There is a storage account along with a container created. So let's go ahead and run that. While this is running, I'd also like to highlight The general directory structure for the repository. There's two main directories in the repository: a modules folder, which declares those reusable bits of Terraform configuration for often created resources. So we have one for a storage account with its declared variables. We have one for a key vault. We have one for our metastore, and then we also have one I've called Databricks that creates the workspace and the access connector. The other folder is the live folder, which contains all the subfolders for resource declarations that represent live resources. So in our case, we have a dev folder that has both the workspace, which is the first configuration we ran, along with the workspace administration, which will be the last one that we run once we have created the metastore. In general, it's a good idea to take some time and plan out how you want your resources coupled, since Terraform will manage all resources in a root configuration in one state file. If resources aren't on the same life cycle or tightly coupled, it's generally a good idea to manage them separately in different state files. State files are Terraform's link between your configuration and the live infrastructure. When you run a Terraform plan or apply command, Terraform compares your declared configuration with the state file and the existing infrastructure to create those plans and make changes to live resources. All right, looks like we've completed that. Let's go ahead and run up to, but not including, our last command. This last apply command I'm going to run manually via the console. During testing, I've noticed that we occasionally hit a transient error where the storage contributor role that we assigned to the Databricks access connector in our first configuration actually hasn't fully propagated, and the Databricks provider throws an error when we're creating the external storage configuration. Another thing I'd like to highlight while we run this is, let's go ahead and take a look at the plan. So this is our workspace administrative resources. So I'm creating a user account for John in our workspace that we've just created. I'm creating the external storage credentials. I've got a key vault back secret scope that we're creating. I'm assigning John to the workspace admin role or admin group. I'm also creating a link to that external storage account we created in the first configuration. And we're also creating a example cluster here so that John can show you how to get your data moving once we get that all spun up. Let's take a look at the workspace variables while we have some time here. Something to highlight is there are multiple ways to define variables and pass them into Terraform. For this workspace configuration example, we're using a variable file that defines static values for declared variables for known configuration requirements. So here we're declaring variables for things like our Databricks SKU, right, the key vault SKU, how long are we going to retain deleted secrets, numerous things for our storage account, along with some kind of housekeeping general things like tags. And so you can leverage what they call TF-var files to define values for these variables. For example, if you're going to be using Unity Catalog in your workspace, you need your Databricks SKU to be premium. So that's something you don't have to remember. Configure it once, deploy it many times. These files are automatically consumed by Terraform when running CLI commands, so you don't have to explicitly specify them. It's also a good idea in your git-ignore file to ignore all these variable files. I provided examples in the repo. Sometimes these variable files can contain information, again, you wouldn't want public. And then, let's see. Terraform also, so Terraform reads all configuration files at the root directory and conflates them. We leverage that fact here to break out our variable declarations into their own file. Having separate files doesn't change how Terraform operates at runtime, and it's only there to help organize our configuration. So on the other hand, for variables that are not known before we kick off our deployment, for things like our workspace URL, our workspace ID, and our connector principal ID, you can query Terraform in that root directory using the output command, and it'll give you back all of your declared outputs for that configuration. You can see examples of declared outputs in here. So once our key vault is spun up, for example, we need the key vault ID for the key vault back secret scope. So we declare that as an output, and then Terraform makes it available via CLI commands. And then you can pass those in either via explicit variable declarations here. So right, so our workspace URL is being assigned to our workspace variable, which we've gathered from the output. Or if you find that you have a bunch of variables and your code looks cluttered, you can go ahead and just dynamically create one of these variable files on the fly, and then explicitly pass in a var file into Terraform. All right, so it looks like we've hit the error I was talking about. So the contributor role in a storage account is not set, or the managed identity does not have access. I mean, we've gone ahead and we've assigned that access, so we're just kind of waiting around to see if it'll run. So let's run that again here in a second while I highlight the different ways you can use providers. So for our workspace example, if I go to the provider declarations, you can see that I'm just passing in default values into our Databricks provider declaration. So this will use like account level APIs to create our workspace. If you compare that to the workspace administration provider declaration, you can pass in additional values such as the host URL and then an authentication token, and that'll actually use the workspace APIs to create clusters, for example. And then another thing, as we're wrapping up here, that I want to highlight before I pass it over to John, is that for these last two configurations, both the Metastore and the workspace administration, I've leveraged the fact that SCIM provisioning is already set up for our Azure tenant. So I'm able to authenticate with the workspace using an Azure AD personal access token. SCIM is not yet set up for your organization. You can use a Databricks personal access token created via the workspace UI, and you can pass that in here. So in summary, we've seen how you can leverage infrastructure as code tooling to bake in best practices into your Databricks environment creation. This includes leveraging an access connect for Databricks, for workspace data access, creating a region's Metastore to enable Unity Catalog for data governance, which John will show more of. And while we didn't demonstrate setting it up, highlighted SCIM provisioning to federate your Azure AD identity provider with Databricks to sync users and potentially AD groups. More information is available on the public repository with links that provide a step-by-step guide on setting that up for your organization. So now that we've got that infrastructure and permissions all set up, I'll hand it over to John to explore that data roadmap.
All right, thank you, Brian. Let me share my screen here. And there we go. Okay, good afternoon, everyone. Thanks for joining us today. In this part of the workshop, we'll be exploring the best practices for managing your Databricks Lakehouse users groups and integrating with enterprise IAM tools, and talk through policies for organizational success. So let's get started. One of the key aspects of managing your Databricks Lakehouse is leveraging infrastructure as code, as Brian has demonstrated. With infrastructure as code, you can automate the deployment and configuration of your infrastructure. I'm going to show you how quickly we can now jump into a notebook and start querying data. So the first thing I want to do here is log in. I was trying to log in as Brian was bringing this up, and of course it wasn't all there yet. So we're going to try this again. And I just wanted to show you how the Azure AD and single sign-on works just flawlessly. The skim tools, all those are wonderful. So I'm logged in now. I didn't have to add any users. I didn't have to do any AD groups, didn't have to assign any privileges. That was all done through Brian's Terraform work there. So one other thing I want to do is start my cluster real quick because that takes a few minutes to bring up. So I'm going to go ahead and start my cluster here. Oh, it's already up and running. Okay, so first let's talk about two essential components of your Databricks Lakehouse, the Metastore and the Unity Catalog. Brian touched on this a little bit. The Metastore is the top level container that stores metadata about your data assets like tables and views. Think of it as similar to a database schema or table structure. On the other hand, the Unity Catalog is a unified governance solution that manages all data and AI assets within your Lakehouse, including files, tables, machine learning models, and dashboards. So I'm going to bring up the workspace, which you're seeing right here. And I'm going to click on this here. So the Unity Catalog provides a range of powerful features that enhance your data management and governance capabilities. Some key features of the Unity Catalog include define once and secure anywhere. Unity Catalog enables you to administer data access policies across all workspaces and personas from a single location. Standards compliant security model. You can grant permissions at the catalog, database, table, and view levels using familiar ANSI SQL syntax. Built-in auditing and lineage. Unity Catalog automatically captures user-level audit logs and lineage data, allowing you to track data usage and access, and data discovery. With Unity Catalog, you can tag, document, and search for data assets, making it easier for data consumers to find out what they need. And that's up here. You can do some really nice searches in your Databricks console here. Next, let's walk through the importance of setting up admin groups for Metastore, workspace, and account administration. So Databricks seamlessly integrates your identity access provider using Skim, which Brian talked about. This integration allows you to federate users groups from your IAP into Databricks at regular intervals. By assigning users to groups in your IAP, you can efficiently manage permissions in Databricks. It's best practice to assign permissions to groups, not individual users. So I'll say that again because it's real important. It's best practice to assign permissions to groups, not individual users. Otherwise, your life will be a nightmare managing all that. So now let's understand the role of Databricks account admin, console, and explore workspace admin functions. So I'm going to bring up the admin console here. So Brian made me workspace admin. So I am able to see all the different things related to the admin console here. The Databricks account admin console is a powerful tool that provides granular control over your Databricks workspace. Let's take a quick tour of this. So here we have the Databricks account admin console open. Within this console, you can access various tabs that allow you to manage your workspace and account settings. So let's go through each one of these. These users here, Brian added me as a user. I was already a user, but he applied my permissions, made me an admin. I have workspace access, Databricks SQL access, and unrestricted clustered creation access. So he did that. I didn't have to do any of that there. So these users were synced from Azure AD seamlessly using the Skim tool.
Hey,
The
John.
service principle. Yes.
Sorry to hop in. Do you mind making your screen full screen, please?
Oh, yeah, let me make it bigger and full screen. No problem.
Perfect.
Is that
Thanks
better?
so much. Yeah, that's perfect.
Cool. So the service principles identifies, these are identities that you create in Databricks for use with automated tools, jobs, and applications. And then last but not least is groups. AD synced groups can be added to your workspace. So if you'll see this right here, we have admins and users. We don't have any AD groups synced right now. These are just standard Databricks groups that are added when you create the workspace. And I'm actually in one of those because he put me in there with the infrastructure as code, the Terraform. So you must manually add the AD groups you need to your workspace. All AD groups are synced via SCIM and are available for addition into the workspace, but you must add them. And at first I thought this may not have been a good thing, but the more I was dealing with different workspace environments, the more I liked that because you can apply different groups to different workspaces as needed. So now that we have an overview of the admin console, let's see how we can add a group to a workspace and assign ownership of the catalogs. So here's the admin console again. To demonstrate, we're going to add a group to the workspace so that we can assign them ownership of the catalog, because we always want to assign permissions to a group, not a person. So under here, we're going to go back to groups, and I'm going to add a group. And there happens to be an AD group out there called IAC Workshop Admins that we've created that came across. It's synced from Azure AD right into our Databricks. So we're going to add that. And I happen to be in that group as well. Brian and I are both in that group. So from this group now, we're going to need this at a later step. So now that we have this group assigned as the owner of the catalog, let's move to the next step. I have let me minimize this for just a moment. I'm going to import some code so I don't have to type it all. That's not that one. Let's see, import. Here's my example file that I'm going to use to get some code, to get some data flowing. Okay, we've got that in here now. So I've imported that. And the first thing we want to do, let's bring that up. There it is. This will also be available after the talk here. We'll provide this notebook for you guys. So the first thing we want to do is we want to create a catalog and schema for the table. So I'm going to run this, and I could step through each one of these, but I'm just going to actually run this. Right here, you can see that I needed that AD group because I'm going to assign the catalog ownership to that user. I'm going to assign the schema owner to that user, that AD group. And then I'm going to also assign the table to that group as well. So I'm going to do all that using the normal SQL ANSI access controls here. And I'll probably get an error because it's a live demo. Okay, it wasn't started. I thought I started the cluster, but I guess I didn't. Okay, we'll start that cluster. So we'll just step through some of this here. So again, catalog level is your highest level. Underneath a catalog, you can have multiple schemas, and underneath those schemas, you can have multiple tables. So this line number 7 here is where we create the catalog against a Azure storage account. So Brian was working with this right before he handed it off to me. Some of those permissions weren't propagated yet, but as he created that, it finally came across, and that's where we're going to store our data. Our catalog will be stored in that external storage account. And I'll jump over there and show you that real quick. So in our data tab under external data, we have external locations. Here's that external location, and you can see here's the storage account. And you can see that if he's the owner of that, we always want to change that to the AD group. I'm going to leave that as is now, but we always want to change that and never want to have a user as an owner. But this is where we grant access to the storage account. And when I run this, we're going to see that we need create, manage, or create external table checked because we don't have that at the moment. So we're going to jump back over and we're going to see if we can get that to work here. I'm going to bring up another window real quick so I don't. Then let's go to the workspace and we'll try that one more time. So the cluster's up. Up here, we can see that our cluster is now running. And I'm running the code. I'm going to get an error here. And that's because I don't have access currently to create a table. Permission denied. User does not have create manage storage on external location external. So I go back over here. I go to my external location. External. And I'm going to grant myself privileges to create manage storage. I'm just going to do all of them for purposes of a quick demo here. I'm going to assign this to an AIC workshop admin, which I'm in that group. Since I am the workspace admin, I can do all these things. You have to be a workspace admin to do these. Okay, now that that's there, we'll try this command again, this set of SQL. And we might get another error. This is where we were getting some issues with it not quite being propagated yet. And Brian and I have talked through this. We think it's because this takes a bit to propagate out to the storage account. So we'll try once more here. And we're getting that. So I'm going to keep going here. We'll come back to this step in just a minute. So it sometimes takes a few minutes to propagate that. While we wait, I want to go over some of the access controls around the Unity catalog. So let's flip back over here to the data tab. And I'll point you to the catalog layer here. And let me go back one more to show you. Here's the catalogs. So to create a catalog, you must be a Databricks Metastore admin or have been granted the create catalog privilege on a Metastore. That gives you some fine-grained access to who can and cannot create catalogs. The catalog owner, you can't see here, we don't have a catalog that we've created yet, but the catalog owner is a set. So you set the owner of the catalog to a catalog owner group, not a user, and the catalog owners have full permission to assign permissions to the catalog. So if I click on this, I think this is a Hive Metastore, so that's not the same thing. Let me try once more to get this running because there's some things I want to talk about. Let's see if it's propagated now. See if this will work. Let's see here. Looks like it's going to run this time. This is creating our catalog, our schema, and our small table that we're going to use to store data into a Delta table. So that's done. We're going to refresh this page and then we'll have a little bit better visibility. Here's the catalog we just created. You can see that it got assigned the owner AIC workshop admin using the SQL ANSI controls. And we also have the permissions tab here. This doesn't have any permissions at the moment, but anyone under the AIC workshop admin will be able to do anything from the catalog down on this. And this is not quite showing. Sometimes you have to refresh the page to get that to show up on the left side here. So the catalog permissions, I just walked through that. The schema permissions, you use schemas, you can do use schema, select, modify, execute, create table, and create function. And that's here. Let me show you that real quick. These are the permissions for granting a catalog. All of these. These are the permissions for granting a schema. Here's all those. And then last but not least is the table. You have permissions to, you can allow certain access, select, modify privileges for the table. So all of those are, as you can see, leveraging the Unity catalog. You have very fine-grained, low-level control over your data. So best practice is to use groups to manage permissions across your Unity catalog. So now we're going to go back over here to our notebook, and we're going to load the data into our Delta table. So now that we have a catalog, schema, and a table, we're going to just grab some data. This is weather data from Open Mateo. We're just going to get some data from a few weeks ago. And let's try that again. We get that to run. Failed to fetch. Wonder if my cluster's not working this time. Let's try that again. Huh. Okay. Well, what we wanted to do here, walk through this. We fetch the data, we get the response, we put that data into a data frame, and then we load that data into just we read the data frame from Spark, and then we load that into this DF final. And then the next thing we do, let's try it once more, just see what's going on with that. There we go. I don't know, didn't work that time finally. So we got all of our data there. The next thing we're going to do is we're going to load that data into a Delta table. So this step, we take we take the data, the table name, we take the data that we just got from the load of that temperature data, and we're inserting that into the Delta table. And so that's done. And now let's just query that real quick here. So this is querying, that's queried the Delta table where temperature is greater than 9. And then we're going to do just a quick Spark query on this just to show that as well. And then let's jump over to the data tab and let's just see if we can see any sample data in there. And there's the data. All right. So in summary, Brian and I have shown you how to go from zero infrastructure to querying the data in less than 39 minutes. We've covered best practices for managing your Databricks Lakehouse, including infrastructure as code, Metastore, and Unity catalog setup, admin group configuration, applying permissions, and hopefully we've made a little more sense of the Databricks account admin console. Remember to explore the Databricks documentation for more in-depth tutorials and best practices. And with that, we'll open it up for Q&A.
Thank you so much, John and Brian. Appreciate you guys going over all that great information. As John mentioned, you are welcome to add in a Q&A, a question into the Q&A section. You are also welcome to raise your hand if you want to ask that question out aloud. Just let me know and I will click on the allow to talk so you can ask your question live. We'll wait just a moment to see if anyone has questions. Okay, well, thank you all so much for joining. We will be posting the recording of this on our social media tomorrow, so be sure to be following us. We'll also be announcing any of our upcoming webinars or events, events that we are speaking at or attending. So we'd love for you to connect with us on that as well. If you have any further questions that you did not get a chance to ask today, feel free to email info@bpcs.com and we will make sure to get back to you. But thank you all for joining, and thank you so much, John and Brian. Have a great day, everyone.
Thanks, everyone. Bye.